Eric Kaltman. So Eric has a bachelor in Chinese studies and history and also a master's in art and Asian studies and educational game design. And he had a short stint as a programmer and also game designer, and then since 2011 started his PhD, which he's about to finish, in computer science at the University of Santa Cruz. And he's really interested in researching but also practicing of how to preserve historical games, how to document them, and not only the artifacts of software and hardware as such, but also how to preserve the actual gameplay, right? Like what have people experienced, how did they play these types of games. And so he's currently also a project manager at the Game and Metadata Citation Project, which is a collaboration between the Stanford library and also the University of Santa Cruz. So it's a pleasure to have him here, and today he's going to talk to us about troubles with game history, objects, and gameplay. So, well.
Okay, so as Ingmar very nicely introduced me, that is the title of my talk. I also had an introduction slide, which just basically got annulled by your nice introduction there, so we're all good. I started doing game preservation about 8 years ago, while I was in the midst of other academic pursuits. And I decided that it interested me enough that I wanted to go back to do more of a computer science technical approach to preservation. I do that at the Expressive Intelligence Studio at University of California, Santa Cruz. And I actually got started in game preservation here 8 years ago, working on Stanford University Library's Cabernetti collection of classic games, which will come up in a little bit. The general structure of this talk and why it's kind of engaged in trouble. I'm going to talk about game preservation, the preservation of games as objects, common preservation narratives, and historical commitments that you make when you do preservation of games. I'm going to talk about how work into technical and developmental history of games and of software systems can add certain problems to this conception of how preservation works for computational objects and game systems, and kind of what limits it reveals about the initial commitments that we have to how we preserve games. And then the end of this talk is going to kind of go into implications for the future and a stronger look into gameplay preservation as a means to help out with some of the issues that I'm going to come up with through the rest of the talk. So when I talk about the trouble with games and game history, I'm talking about games as software objects that need to be preserved. So they are data organized into computational abstractions that are dependent on some sort of computational system for expression and have generally been historically stored on physical media. The standard preservation model that we usually kind of function with, I choose the NES, which for reasons I'll talk about later. This is the Nintendo Entertainment System, for those of you who are unfamiliar or were not born in the mid-'80s. The standard preservation model kind of looks at three specific things. It looks at the executable program, or the software data, the means of conveyance, or the media format, and then how that interacts with the computational platform. All three of these things combined need to kind of be preserved or considered when you're doing game preservation. And they all elicit a specific set of challenges as technological objects. The first means is that if you have a piece of data or a physical object that you need to preserve that's technical, you need a good way to describe it. As far as games go, you can talk about Adventure as a terminal game, which is a text adventure game made in the mid-'70s. Or you can talk about Adventure as the Atari 2600 game that was released in the early '80s. Both of them are called Adventure. Both of them have very significant historical place in games. Both of them have the same title and ostensibly some similar affects. And so if the person who's dealing with this object isn't fully aware of them, you need a way to describe it so that someone else can find it in a collection at some later point. And while everyone here has selectively decided to come to a game studies lecture, the general populace of people who need to be dealing with preserved software data in institutions don't really know or care as much about the difference between what they would consider minute historical or technical things with games. So we decided to start a project called the Game Metadata and Citation Project to essentially create a set of controlled terms for how to describe games in preservation collections, talk about ways to embed correct description of software and games into library metadata standards that already exist, so that people could kind of co-opt them into systems that they already used. And then just provide essential guidance and information for collecting institutions that need to preserve games or preserve software objects. There's also a citation component to the project, which I will not talk about, except to say that that is also a very large issue, in that if you have objects preserved in a collection, the means to cite it or find them again, or even talk about and discuss them in academic writing is kind of non-existent. There's no standard for citation of software, and we're kind of working on that right now. As the project goes on, maybe I'll be talking about it at some point in the future. Another kind of preservation issue that develops out of the organization of game collections is canonicity. Whenever you're kind of making a decision about what to include or not include in a software collection, you are making a distinction about what's historically important and what's not historically important for the future. So for people who are deciding what they want to or will not be able to study going forward. The problem that this kind of develops that we got into when we were doing the game metadata and citation project, because we were looking at what game systems exist, what types of things do you need to describe, is that there's an insane number of dedicated video game platforms that have existed over the course of time. Now, this list isn't actually even exhaustive because it doesn't include operating systems and it doesn't include what I would term general computing devices. Most of the things on this list, in fact, pretty much all of the things on this list were designed to, play games. And when you get into these types of numbers of platforms and things that have existed historically, you kind of need to decide what you're going to include and what you're not going to include. And this gets even hairier when you move into the whole class of computational objects. For instance, you have games that are really popular like Super Mario Bros. 3, Myst, and Doom, but those are the ones that were made for the TI-89 graphing calculator, because there's an active TI-89 graphing calculator community. And in my estimation, this is not a canonical version of Doom, but we are making basic assumptions about who programmed things where and what versions of things are significant that then impact the understanding of games history going forward. Also, in relation to Doom and canonicity, when you try and preserve a game, say you have Doom in your collection or Doom as a preserved object, which Doom are you talking about that you're saving, right? There's many different versions of Doom. You need ways to describe what versions you have in a repository if you are actually taking the data from a Doom disk and putting it in some sort of digital collection. Or if you just have it physically, you want to have it described in a way that someone knows what type of game they're getting or what version of the game they're getting. And so the distinctions between the objects that you're dealing with kind of get really messy very quickly when you actually try and put them into practice or put them into game collections and describe them effectively. Other stuff that kind of comes into migration from the more physical end, comes into preservation from the physical end is migration. A lot of the media formats that things have historically been stored on are kind of obtuse. You have, in this example, SNES, Super Nintendo system, and Sega Genesis cartridges, and on the right, an extractor for the Nintendo Entertainment System. So there's specific hardware that's now designed to get the data off of all of the intricate and multivariate media formats that you'll find in a software collection. Now, this is actually easier for more popular formats, but you have other formats that are less well known that are made by popular companies like Nintendo that are significant historically for interesting reasons. This one is a Nintendo Famicom Disk System floppy disk for a floppy disk addition to the Nintendo Famicom, which is the Nintendo Entertainment System that existed in Japan. And this specific disk is actually the original launch platform for The Legend of Zelda. So if you want to play the original conception of The Legend of Zelda, you play it on the Famicom Disk System, which was released only in Japan. And as an interesting historical note, the reason that Nintendo cartridges had to get a battery backup feature is because they needed to emulate what was already available as on the floppy disk format that existed in Japan. So there's this notion that certain media formats might be esoteric, but they're also kind of significant to specific ideas and narratives in game history. Storage is also a problem, generally in preservation. I'm not going to cover it too much here, except that if you have a physical item, as long as you don't care about the data on it, you can store it pretty effectively because it's literally just goes in a box and goes on a shelf. This is a picture of the Stanford Auxiliary Library 3, Sal 3 here at Stanford. And there has been some issue organizing for how to put boxes of software that just need to sit inertly in a collection for long periods of time. But the more pressing issue for them is actually getting the data off of the disks first, because if they sit there for too long, the data will actually get corrupted and disappear. Now, if you have these items in a collection that are stored and you've described them and that type of thing, the other kind of preservation challenge is representing them back to a user or an academic or someone who might need them in the future. For physical items that you have an actual physical piece of hardware with, it's not trivial. I won't say it's trivial to set up a Mac and get it running from 1984. But if you have the actual machine and the actual media format that goes into the machine, you can kind of hook it up. You can get back the physical experience of playing it without as much, I guess, need for technical wizardry that I'll be talking about in a second. The problem with having physical items that you're storing and getting back is that you need to do maintenance on physical hardware continuously the entire time you have it, because eventually it'll degrade and go away. And so we, in general preservationist perspectives, tend to kind of say that preserving hardware is going to be a very specialized niche thing, and what you really need to do is get the data off of the physical items and then find a way to represent that data to an end user. One of the more common ways of doing this now for a certain class of items is emulation, in which you write a software program that can interpret the data you have taken off of a physical media and then represent it through some other computational construct. In this case, a browser window for the Internet Arcade, which is one of the more popular online places to look at emulations of games. Now, emulation also has kind of issues itself, specifically due to the lack of it having the same physical instantiation of the original object. This is a picture from the Stella emulator that is emulating. This is kind of an emulation, an emulator doing a physical emulation, so it's kind of a nested thing. On the left side is the display from a modern LCD screen, and on the right is an approximation of what it would look like on an old CRT television. And you can see that this is actually a racing game, and so on the right side, the tires' graphics are designed to blend together based on their expectation that they're being shown on a CRT. So it actually has a tire that is kind of visible. On the left, it looks like kind of some odd spider monster. And so a lot of people who play games today, even in browser emulation, are essentially wholly unaware of why certain graphical things look the way they do, and it's essentially because there was an expectation on the part of the developers to use the, I guess, economy of pixel blending at the time to kind of save on some graphical processing for other places. Again, with emulation, another problem is that you're not playing your Nintendo Entertainment System with the little controllers on a television in your living room. You're looking at it in a browser or through your laptop. And so there's a specific amount of physicality and embodied interaction that gets left on the floor when you approach representation through emulation in this way. Okay, so essentially preservation challenges for preserving software or preserving games, the top 5 here are kind of the big ones. The next kind of issue with preservation, which is less of a challenge and more of a pack of assumptions, is the scoping of the preservation activity. So when you look at the history of game objects, general histories of games tend to focus on just the lineage of commercial objects, right? You have someone develop, in this case, in this selection of things that I put on the screen for reasons that will remain secret until later, you have Pong being developed and put in a bar down the peninsula and then getting translated into a home Pong console, and then Atari makes the Atari VCS or 2600. The game market crashes out, and then you get back this victorious resuscitation with Nintendo, leading into a notion of, I guess, platform generations. where you have the Nintendo Entertainment System leading to the Super Nintendo, leading to the Nintendo 64, going on from there. There's like this generational narrative for how video games developed after that point. But the kind of, I guess, problem that I always have with focusing on, pre-assigned significant historical markers in game history is that you essentially start choosing like what valid members there are of Game History Club. Like there's a lot of games that were made from 1978, well, since the commercial game industry has existed, and a lot of the preservation practice and a lot of the focus ends up being on things that were, commercially successful and incredibly viable, which in some sense is rightly so because you want to focus on the things that were popular and that are staying in people's imagination. But in working with the collections that I have at Stanford, you find a lot of stuff in historical collections that is kind of just interesting as indicative of the time, or that is trying to do things that are different or what you would think would have been new now but had been actually tried in the past. I always put the Communist Mutants from Space box in some of the presentations for preservation because I just think it's, well, A, it's kind of hilarious, and B, it was made in a specific time and place for a specific reason. And then on the right, you have 3 Mile Island, which is actually not a disaster simulation. It's that happened. It's this game to, play with the management of a nuclear power plant, which I haven't really encountered again. But so there's this whole swath of activity in the history of games that gets swallowed up essentially when you just kind of focus on certain commercially successful platforms and games. And then this kind of bleeds into the actual preservation effort by communities, right? A lot of the more popular systems have a significant amount of dedicated emulation effort by the games community, fueled by this nostalgia for the specific stuff that was commercially popular. And so you end up with this selection bias towards the history of games and towards the preservation of game objects based on this activity. Okay, so getting onto technical history and what does it add to preservation and what limits does it reveal. When you view preservation through that standard model that I had kind of put up at the beginning, and we have all those different issues with description and I guess quantification of the games, when you start getting into the study of them even more deeply or get down another level, it just ends up getting more complex, not less. For the rest of this talk, I'm going to kind of be positing a model, a straw man model of games based on Chris Crawford's Listen, Think, Speak loop. This is an illustration from Steve Swink's book Game Feel. I would really recommend checking that book out if you're interested in the, physicality of expression in games from an engineering perspective. Now, the Listen, Think, Speak loop is a relatively simple model. It basically posits that in any game interactive system, there's a human that is listening, thinking, and speaking to a system that is also listening, thinking, and speaking. So it doesn't have a place of priority or a hierarchy in the interaction. It's more of just this combined feedback loop. And a lot of the preservation practice that we have right now is kind of focused on preserving the right half of this diagram in hopes that eventually it will inform the left half, that you kind of get all these old objects and preserve them so that you can study their history and reveal something about how the human interaction worked. But when you even start kind of positioning this, construct inside larger historical currents, for this specific example, I'm going to just talk about some technology studies and some development practice history. It starts to kind of complicate our understanding of how to preserve games even more. For instance, if you look just technologically at the objects on this slide, you'll notice that the top left are actually hardware. They're not software. The original Pong machine was a modified television set, modified television hardware. And the Pong home game was a collection of circuits that they don't have source code, right? It's actually a physical construct, whereas everything else on the slide is actually some variant of a MOS 6502 assembly language encoded machine. Now, this is an important distinction to have, and it also kind of complicates our model when we talk about the standard preservation at the beginning, because some seminal items on this slide already don't fit into this idea that there's a separate software that you have to maintain, and so you kind of get into a distinction of basically like where to fit in this hardware history, given that now there's a lot of okay. So it doesn't kind of fit into the conventional preservation model that we've organized earlier. Another kind of way that this gets complicated is if you kind of take a granular look at any specific item here, like for instance the NES. This example is motivated by Nathan Altice's book I Am Error, which I would highly recommend if you're interested in the history of the Nintendo Entertainment System. But if you look at the Nintendo as a classified object, it starts as the family computer in Japan with its attendant Famicom Disk System, and then gets released in the United States as the Nintendo Entertainment System. And it also kind of has a collection of peripherals and other input devices that interact with the game and further complicate our ability to do preservation. Because if you're doing emulation, do you want to write a software emulator of Rob? Is that something that you really want to? This Rob is a interactive toy that came with one of the original Nintendo systems where you could move little discs, spinning discs, to play games. And from some perspectives, it's a very interesting historical object. From others, the preservation of it is basically just putting it on a shelf, and I don't know if you'd want to do some sort of grander software emulation of Rob. But if you go even deeper into the Nintendo, you realize that even though it existed as a singular object, as a basic platform that you would buy, the cartridges and the games themselves actually included essentially these memory management controllers or mappers, which was additional powerful hardware that let you do and express more with the games. So that the graphical capabilities and the sound capabilities of the system actually got significantly augmented over the entire train of its existence. And so this distinction that we have for like generational games, or like the NES existing and then the Super Nintendo existing, actually doesn't really work as well when you kind of look at the train of how games had developed on the system. So just as an example, which I hope this isn't that loud. We got it? OK, good. So this is Mappy, which is a port of an arcade game from 1983 to the early NES. And its entire design is just a direct emulation of the arcade game that it came from, right? It's not trying to do anything or really exploring anything outside of the confines of the arcade design grammar from which it came. And it's what you get when you get initial early Nintendo games, right? They're coming from a different design. They're coming from a different design paradigm and structure where you have a high score and lives and that type of thing. But if you go to the end of the NES's life cycle, after many years of development and many kind of advances in the cartridge technology, you get a game like Lagrange Point, which is one of the last Konami games released for the system, and the only one to use the VRC7 mapper, which gave it much more advanced sound capabilities. And this game is not really an arcade game, right? It's a full-fledged role-playing game that has an orchestrated soundtrack, opens with a very long cutscene, takes hours and hours to complete, and I guess design and aesthetically has a lot more in common with like early Super Nintendo games than early Super Nintendo games than anything else, right? There's this idea that the game generations were really strict boundaries, and if you look technically inside the machine, you see that they've actually kind of advanced much more, I wouldn't say smoothly, but there's kind of a significant amount of advance even within a generational cycle of the expressive capability of a platform. OK, so that's kind of, if you do some deep platform or technical studies, you reveal certain details that you might want to consider for later preservation that would not otherwise be apparent. Another thing that you can do, which is like what I'm also very interested in, is studies of development practice and how the preservation of objects with this standard idea that you have just the data that you're saving and studying. If you want to really understand how the system worked or was developed, you need to get into actually the history of its development and resources dedicated to figuring that out. And one of the major ways that is generally talked about for doing that is you just get the source code for the object, right? Like you you have a game and then you want to figure out how it works. And if you can get the source code, you get to learn more about how the system was architected and who designed it and how it worked. And one example that I've looked into a little bit is MUD, which is the multi-user dungeon 1. 1 was actually added after it was made by Richard Bartle to make sure you knew it was the first one. It was essentially the first multiplayer online virtual world. It was text-based. It was made at the University of Essex in the late 1970s. And we have the source code here at Stanford. You can just download it off the website, which is kind of nifty. But if you look at the source code, it's actually kind of hard to parse. It's written in BCPL, which is a progenitor to the C language, designed by Martin Richards. And the version that MUD was written in was actually it was written between 1979 and 1986 at the University of Essex using the University of Essex's own implementation of the BCPL language. So getting this running again, or kind of figuring out what's going on in the source code, requires you to essentially get discordant references from different time periods to try and construct when certain things in the code had been written at what times. And there's absolutely no compiler for this. So if you actually wanted to try and run the thing again, even if you have the source code, you need a ton of other dependent objects just to get the game and the system running again. The other reference for BCPL is actually the language reference by Martin Richards, who made it. But this book is from 4 years after the University of Essex project started, so it actually includes a lot of references to things that were not available to the people in 1979. And essentially the way that you figure out this works is you email Richard Bartle and some of the developers and kind of get into more of a conversation about how this system worked, right? Like when you start looking into development practice and development records, you realize that when we're preserving the games and just the singular objects, you can't get at a lot of the history that you would otherwise need to get to, and so you need to fall back on more, tried and true methods like oral history and like direct contact with people. You can't just get to the history from the data itself. The other thing, just as a general problem with development studies that way, is that source code is very unavailable. There's actually a Wikipedia page devoted to commercial games that have source code available because it's not that common. It's actually a really nice page to look at if you're interested in specific games or have specific things to develop. Most notable games with source code available, SimCity and Doom, which is actually something I'm looking into at this moment. The other problem is that there's not a lot of tradition for how to do the history anyway. There's no history of game development page on Wikipedia. There's actually a direction to it, and then it's just hanging there, right? So there hasn't been a lot of concerted effort, even within the development community, to kind of figure out how to preserve and talk about their heritage. We actually worked on a project, another joint project between Stanford and UCSC to kind of define that for archives. One of our notions was that if you kind of gave a guide for how to deal with the records of game development, maybe institutions would be more willing to actually take them on or deal with them or figure out how to appraise them. So from the two examples that I've talked to with technology studies into the NES and getting into more development practice histories, the preservation of the game objects isn't basically enough. And even when you have those sources, they're kind of difficult to access and collect and describe in the level of detail that might be useful for specific people in those disciplines. Also, the technical study stuff that I've talked about reveals a lot of holes in preservation practice. Like you're trying to preserve the games as objects, but you need a lot more of the historical context around them to be preserved as well, in order to get a more fuller understanding. And it also privileges a specific type of historical analysis. The game data that you save lets you only do a certain number of things analytically that you need to then supplement with other types of preservation practices and other types of historical study. And another large thing, which kind of came out of the MUD example for me personally, is that when we do the preservation work, there's not a lot of discussion, or there's not as much discussion as there is, of how difficult it will be to deal with the technical considerations of objects at the time that you're preserving them or into the future. The MUD example for me actually kind of kicked off the last part of this talk, which is it's a multiplayer online game that's server dependent. So there's a lot of specific technological dependencies that we can never reclaim to get that thing to run again. Like it'd be a very, very Herculean effort to actually get Mud 1 running. Luckily for Mud 1 specifically, it was actually ported to C. So if you want to cross-compare between the C version that works and the BCPL version that doesn't, feel free. I'm sure there's actually quite a lot of interesting stuff in there from a programming languages perspective. Essentially, all the stuff that complicates that standard preservation model has significant implications for the future. I guess the last third of this talk is kind of dedicated to this notion that the standard perception of game preservation and game history is rapidly changing and fastly becoming outdated. When I think of a game being born in 1983, my historical center for them is like the Nintendo Entertainment System. It's where I first got exposed to video games. It's how I kind of like demarcate game history for myself internally. And when I think about preservation practice, I was used it earlier in the talk as like a standard, one of the objects for a standard preservation model that we've kind of developed through the research that we've done. That's a very North American-centric view. If I was born in 1984 in some other country or other part of the world, Nintendo would not be my defining object for my history. It would be something else like a Commodore Amiga or the Famicom, which is the Japanese version of this. But the thing is that a lot of the work in preservation is being thought of and conducted with a mindset towards these types of objects. And then whenever I think about people who are, grew up later, were born in 2000, some people in this room who are much, much younger than I am, right? Like this is a conception of a game, to vast numbers of people in that generation. And this is a very, very different preservation object and a very, very different, model for both software and interaction. So if we kind of look at the standard preservation model that I brought up in the beginning, where you have data that's put on a storage media that's conveyed to a platform, if you throw a phone into this, it gets a little buggy. There's no storage media. It actually kind of gets data put on it from the internet. And so there's a totally different distribution paradigm. There's a different reliance on network connections and sort of other dependent systems that was not present in the earlier preservation conceptualization. And so I'm kind of referring to this as like a network contingent model for preservation. And there really isn't a lot that this stuff, like we don't know how the previous perspective that we had on this maps to this new paradigm, really, yet. Like some of the description and canonicity issues are always going to be there. Migration and storage for digitally distributed or highly networked objects is kind of a really big open question still. And then representation is also a big problem, because if you have all these things that were dependent on a network connection for distribution and updates, a network connection for playing, a network connection for interaction with other people, when all of that goes away in a decade, the object's not going to function, even if you get the whole code back, even if you get the whole object, if you do this whole thing that we've talked about with getting the data off of or out of the digital distribution system, and you store it on your local computer or your local repository. The representation issues are different. The emulation challenges are also different. And for, I guess, just an expression of some of the gravity of the issue of this, the gravity of this kind of issue. If you start with a basic idea of the development of games or interactive software from 1950 till now, and you think about stuff in the standard model, there's been a kind of just a growth going out. And then for network contingent stuff, it started later, right? And so we're kind of in this space right now. This is highly empirical, by the way. But if you kind of stretch it out, if you kind of go out from here, for the future of humanity, like most of the software objects and games that we're going to need to be saving or talking about are going to be in this newer model that doesn't really comport as much with the standard stuff that I was talking about and the standard practices that we've developed over the last 20 years. And this kind of happens again in with the physical distribution of objects as well. Like you had distribution of physical items that has been peaked and is slowly tailing off, and then digital distribution comes in and effectively takes over going forward. right? So like we're not going to have as many physical items to be cataloging anymore. Everything's going to have to be focused on how to store things in digital systems and get them out of digital systems and get them out of iStore walled gardens and things of that, and like other similar places. And this isn't like that. I kind of phrase this as being scary or daunting, and it is, but it's also backed up by some numbers. So if you go to Moby Games, which is a site that kind of has right now, what would be a canonical listing of the games that exist, there's about 55,000 games for all platforms for all time listed on Moby Games, right? Of those, about 19,000 are Windows games for all versions of Windows. If you look at Steam's current numbers right now, 9,000 games, there are 9,000 Windows games on Steam, right? So half of the Windows games, so not half, I mean, around half in weird math world. A significant percentage of games that have existed for Windows exist right now and are in this newer preservation model, like are in this newer network contingent world. And it gets even kind of crazier with the iOS App Store. This is like recent statistics from last week from Pocket Gamer. There's 534,000 active games on the iOS store, with 207 being added every day. So there's effectively an order of magnitude more games on the iOS platform right now than have existed in recorded history for human production. Now, mind you, the games on Moby Games listing also includes iOS apps in it, so the Moby Games listing is actually like kind of an overlap here. And I guarantee you that a significant percentage of those 500,000 apps are not very good or compelling. But again, this gets back to the earlier point of description and canonicity, is that I don't know if there's some future great individual who's making some terrible app right now that we might want to save, because at some point in the future, that'll be kind of a historical, interesting technical object. And so this gets into this weird inversion. I used to, when I gave archiving talks, talk about how we couldn't go the way of the silent film industry or go the way of the film industry. For people who are unaware, silent film, didn't survive very well as a preservation object. At the time that film was popular, at the time that film started, it wasn't considered a popular or productive medium. A lot of people did a lot of crazy, hilarious, I guess this is my favorite picture. It's a guy literally hacking copies of his own film in half so that no one could pirate them. So it's like kind of DRM for the 1920 set. But essentially, there was this kind of notion rooted in this historical conception of games that there's all these old games, no one was respecting them, no one was talking about their history as much, we're going to lose them unless we do a lot of preservation effort to keep those objects around. And my realization is that we're actually doing a lot of that, and the game community and the nostalgia has kept a lot of that safe. And going forward, we're going to have this kind of inverse problem with games and software and data in general, where we can't keep up with the amount that it's being created, and we're going to just lose a large percentage of it because it's not, I guess, containable in that way anymore. And that the technical challenges dealing with networked objects are also much, much more complex and demanding. And so you will not, instead of losing a lot of the percentage of the earlier objects, you're actually going to continue going forward in the future, just losing more and more of the stuff that's getting created right now. And this kind of brings me to my last point, where the earlier model that I've been talking about was where you kind of save the right half of this diagram, the system, to give you some expression of what's going on with the human and recreate the history that way. But it's going to actually become more of I guess the task is now, or in my estimation, the task is now, we're going to have to do a lot more work to actually just record what's going on with the games and the applications as a way to reveal how the system interactions actually worked at that point in history. So instead of trying to get all these network objects running and emulated and saved for all time, I think it's going to have to be a more of an effort to record how people use these objects in practice and see how these interaction paradigms worked in more traditional archival formats, just so that we have some of the history saved, because I don't see dealing with the other problem in any sort of significant manner other than for things that would be deemed, I guess, very significant. like the only networked object that I can think of that has the level of scrutiny that you could bring to bear is the recent work being done with like World of Warcraft server emulation, where people have reverse engineered the entire production server for World of Warcraft games, and so they can run their own servers against, they can run the original World of Warcraft client against, discrete versions of the server software without Blizzard's knowledge or consent with the people who made the game, right? But that's incredibly rare. That's like an instance of a largely networked game object that has a significant emulation or preservation aspect behind it. And I don't see that being feasible for longer term. Now, the idea for gameplay preservation was first introduced into my brain by James Newman, who's actually talked in this series before, in a book called Best Before, which was written in 2012. His desire for gameplay preservation was much more focused on thinking that the interesting things happening with games right now are how people are playing them and less about the data. And he was also a lot more fatalistic about the ability to emulate older games. There's not a lot of discussion of the problems with future and network stuff in this book. It's more about giving up on trying to save everything that has existed in the past and just giving into doing gameplay analysis of gameplay preservation of what has existed. And so you have this idea now that the development, practice, and technology studies on this side, and then sociocultural studies and embodied experience is going to be more of the way that you're going to find out about the right half of the diagram going forward. This is a little bit more sketchy. We can talk about this if you have questions about this later. But the idea that you can get everything you need for the right half of this diagram going forward, especially for modern systems, is going to get increasingly more difficult. Another part of the gameplay preservation that was not present in Newman's work that's kind of become incredibly popular right now, these are kind of things I just talked about, that it's easier task to record a video of a game and store it in a current repository because institutions know how to deal with video a lot better than they know how to deal with software objects. And that's essentially makes it more future-proof for right now. But that I guess the preservation activity of this type is actually kind of going on right now in a large mass scale. That's just not being thought of in the same way as I think other preservation activities have been thinking of. There's like Let's Play videos on YouTube. There's people streaming hundreds and hundreds of hours of their interactions with these games online. And there's a lot of, I guess, game cultural outputs focused on people exploring and interacting with existent gameplay that can be leveraged or, turned towards a better, basis of study and research for future game analysis and future game studies. Okay. So, in, general summation here, the current preservation paradigms do not properly consider the future of what we need to have for preservation paradigms. The study of game history and game technical stuff will actually be dependent a lot more on non-software and non-technical records going forward, just as an incidence of how difficult it is to maintain and take care of these things. And that I think going forward for specific preservation activity, we really need to leverage in a significant way the fact that there is a lot of activity right now going on to preserve how people are playing games and how people are interacting with interactive software online, and just isn't being thought of as historically significant preservation, because it is, and it may end up being one of the main ways in 100 years we find out how people interacted with networked objects right now. Will not be having the actual networked objects, but just having all these records that people were kind of creating for themselves. This is a work partly funded by the IMLS, Institute for Museum and Library Services, and National Endowment for the Humanities for some of the projects I mentioned. And then this is links for the current work that we're doing on metadata description and on stuff that we have done on game development documentation practice. Yeah, thank you.